Hello children, welcome to Right Tuition Classes. What we're going to learn in this lecture is all theorems of similarity chapter. Correct? We're going to learn everything, every possible things to understand the theorem. Okay, so let me start here. First, I would like to tell you what you mean by the word area. Basically, what is area, children? There are many teachers, they just say area matlab surface enclosed. No, children. Understand the meaning what I say. There are many teachers who say area means surface enclosed. Area means surface enclosed in a geometrical figure. But actually, that is not right. Okay. What do you mean by it? What do you mean by area basically, beta? Area is nothing but a number. Actually, it is nothing but a number which helps you to understand how much region is enclosed, how much region is enclosed, is enclosed inside a geometrical figure, inside a geometrical figure. I repeat the whole thing, children, please have a look here. Okay, what do you mean by the word area? Area means number. Area is nothing but a number, children. Area is nothing but a number, which helps us to understand how much region is enclosed inside a geometrical figure. Now, there is no instrument to measure this area. So how do you measure? How do you come to know this area? Area is always calculated. Area is always calculated. Area is always calculated. Remember this. So different geometrical figures have different formulas for area. Different geometrical figures have different formulas for area. Like I want area of a triangle, area of a triangle. So let me start with this. I want area of the triangle, okay? We're going to discuss about, let me say like this, we're going to discuss about area of a triangle. So if I would say area of a triangle is a number which is going to tell me how much region is enclosed inside its figure. So there is no instrument to measure this, but we always going to calculate. So how do you calculate? So remember, suppose this triangle is there, I name it as ABC. So my first question is, which is the base of this triangle? Children, any side can be the base. You cannot say bottom side is the base. बहुत सारे बच्चे लोग गलत बोलते हैं BC base है क्योंकि bottom side है नहीं. Any side of the triangle can be the base. Then the question is, how do you come to which side should be taken as a base? You should always take that side as a base on which the height is drawn. Like, suppose AD is perpendicular to BC here. 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 So BC is called the base and AD becomes a height. That means that side should be taken as a base on which the height is drawn. मतलब height आपको बताता है कौन सा side को base लेने का. Got it? If the height would have been, please have a look here. If the height would have been drawn on, if the height would have been drawn on any other side, like suppose the height is drawn on BQ is perpendicular to AC. Suppose BQ is perpendicular to AC. This BQ is perpendicular to AC. BQ perpendicular to AC. In that case, AC becomes a base and BQ becomes a height. AC becomes a base and BQ becomes a height. Are you getting me, children? The same way, suppose BQ is not drawn, okay? BQ is not drawn perpendicular, now BQ is not there. But please have a look here. But CR is perpendicular to AB. CR is perpendicular to AB. Now, in this case, children, in this case, CR becomes AB becomes a base. See, CR is perpendicular to AB. So naturally, AB is a base and CR is a height. So I hope everybody understands, okay? Height helps us to understand the base. Height के कारण हम base समझ पाते हैं. Are you getting me? तो आपको triangle समझे, उसका base कौन सा होता है समझ गया, height कौन सा होता है समझ गया. Now remember, what I was teaching you was area, okay? I was talking about area of a triangle. So how to get this area of the triangle, children? The area of the triangle is always calculated. So I just taught you how to identify the base and height. Now area of a triangle, one common formula, area of a triangle is half into base into height. What is that? Area of a triangle is half into base into height. There are some other formulas also, but I'm just identifying this formula for you. Area of a triangle is half into base into height. Area of a triangle is half into base into height. Okay. Area of any triangle is given by the formula half into base into height. Okay, children. Now we go ahead. Here, what I'm going to teach you in this chapter is the first, please have a look here, the theorems. Okay. The theorems on all the theorems of similarity chapter. Please keep in your mind, children. What you're going to learn is all the theorems of similarity chapter. Okay. All the theorems of similarity chapter. Like, if you ask me which theorems, got it? Which theorem? So the first theorem is, so we start with this very first theorem. When you look at it, children, the ratio theorem, it's on areas of the triangles, and that was the reason why I showed you all this. Okay, the ratio of the areas of two triangles. You know what is the area of the triangle? So the ratio of the areas of two triangles. Matlab, two triangles are involved in this. There are two triangles involved. Ratio of the areas of two triangles. Suppose there are two triangles. Okay, one is triangle ABC. One triangle, let me take it as triangle ABC. And you can see here, I just draw AD perpendicular to AD perpendicular to BC. I draw AD perpendicular to BC. Okay. And the second triangle, please have a look here. Second triangle, let me put it like this. There is another triangle here. Okay. It is triangle PQR. Triangle PQR. And you know, it's an obtuse angle triangle. People know this is an obtuse angle triangle. In an obtuse angle triangle, the height is always drawn outside the base. In an acute angle triangle, the height is always drawn outside the base. Okay, people can see this. Okay, the height is always drawn outside the base. This is the base, okay, outside the base. So let me put it like this is my triangle PQR, and you can see this obtuse angle triangle, and the height is PS perpendicular to QR. So which is the height of triangle ABC? AD, which is a base BC, which is the height of triangle PQR, PS, and which is a base QR. Now what you're saying, ratio of the areas of the two triangles. Ratio, you know the meaning of ratio. Ratio of X and Y is X upon Y. Ratio of A and B is A upon B. Just like that. Ratio of the areas of two triangles. Matlab, area of triangle ABC upon area of triangle PQR. Ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding heights. Like base is the BC, which is height here, corresponding height AD. BC को ऊपर AD height है. The base is BC and AD is the height. Okay. Ratio of the areas of two triangles is equal to ratio of the product of the base and height, corresponding height. So BC into AD, which is the base of this triangle, QR into PS. So you can see this as the first theorem. The ratio of the areas of two triangles is equal to ratio of the product of the base and corresponding height. What is the product of base and corresponding height here? BC into AD. What is the product of base and height here? QR into PS. What is the ratio of the product of the base and corresponding height? BC into AD upon QR into PS. I hope the first property is clear. Ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding height. This theorem number one, we are going to discuss four different statements for it. The first statement is clear, I suppose. The second statement, if these triangles have equal heights, this AD and PS, suppose they become equal. If AD and PS are equal, AD and PS are equal. If AD and PS are equal, suppose this is 5 centimeter, PS is 5 centimeter, 5 on top, 5 down, they'll get cancelled. So what you're left with, area of triangle ABC upon area of triangle PQR is equal to, you just told, okay, AD and PS gets cancelled. So what are left with? BC upon QR. Matlab, ratio of the areas of two triangles having equal heights is equal to ratio of the corresponding bases. Ratio of the areas of two triangles having equal heights, AD and PS are equal. Ratio of the areas of two triangles having equal heights is equal to ratio of the corresponding bases. You can see this. In the same way, suppose these triangles have equal bases, BC equal AD, BC equal QR, sorry, BC equal QR. The bases are equal, bases are equal. So this BC and QR are equal, okay? They get cancelled. So what are left with? An area of triangle, okay? Then area of triangle ABC, then area of triangle ABC upon area of triangle PQR. What happens? The bases have got cancelled, okay? Which are the bases with us? BC and QR get cancelled. So what are left with? AD upon PS, AD upon PS. So remember, ratio of the areas of two triangles having equal bases is equal to ratio of the corresponding height. And the fourth property, suppose the bases are equal. BC and QR are equal. So BC and QR get cancelled. AD and PS, the heights are equal. AD and PS are equal. AD and PS gets cancelled. Bases gets cancelled. Heights get cancelled. Bases get cancelled. Height gets cancelled. That means on the right hand side, you have 1 upon 1. But directly cross multiply, what will happen? Area of triangle ABC is equal to area of triangle ABC is equal to area of triangle PQR. Okay. So remember, if AD, please have a look here. If AD equal PS, the heights are equal. PC equal QR, bases are equal. Then children, area of triangle ABC is equal to area of triangle PQR. Area of triangle ABC is equal to area of triangle PQR. So remember this first theorem, I discussed it in 4 different statements. First statement was ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding heights. Then, if the two triangles have equal heights, the ratio of the areas is equal to ratio of the bases. If the two triangles have equal bases, the ratio of the areas will be equal to ratio of the heights. The bases are equal, heights are equal, and the ratio areas are equal. So these are the 4 statements of theorem number 1 in similarity chapter. Correct? Now we will learn the next second theorem. We are going to learn the second theorem. Yeah, it is always the height which identifies the base. मतलब the height of the triangle दिया रहेगा तो हमको base बोलने को आएगा. लेकिन कभी-कभी sometimes, got it, the height of the triangle may not be drawn, but still we should be able to identify the base of the triangle. Now, how this is possible? Because the height helps us to identify the base. Height के कारण ही हम base draw करने हम लोग को ढूंढने में मदद मिलता है. This height has been drawn, the side on which the height has been drawn is identified as a base. But here I'm saying sometimes the height of the triangle may not be drawn, but still we should be able to identify the base of the triangle. So we are going to see it in few diagrams here. I'll just show it to you. The first one, the triangles between same two parallel lines. Suppose there are two parallel lines. There are two parallel lines. This green triangle, this red triangle is between this parallel lines. Why it is said to be between the parallel lines? Please understand this language also in geometry. When the vertex of the triangle lies on one of the parallel lines and the opposite side lies on the other parallel line, opposite side lies on the other parallel line, then we call that triangle as triangle between the two parallel lines. So can you see this red triangle? It is a triangle between the two parallel lines. Yaad rakho please. When one of the vertex of the triangle lies on one of the parallel lines and the opposite side or other two vertices lie on the other parallel line, then I say the triangle to be a triangle between the two parallel lines. Are you getting here? Whereas if you look at this, children, please look at this green triangle again. Okay, its vertex lies on one of the parallel lines. Its other two vertices lie on the other parallel line. Got it? I will call it as a triangle between the two parallel lines. Are you getting me, children? Of course, in our day-to-day language, we mean ये भी हो गया ट्रायंगल बिटवीन द टू पैरेलल लाइंस, लेकिन ज्योमेट्री में इसको ट्रायंगल बिटवीन द टू पैरेलल लाइंस नहीं बोलूंगा। Got it? Triangle between the two parallel lines किसको बोलते हैं? When the vertex lies on one of the parallel lines and the other two vertices lie on the other parallel line, then it becomes a triangle between the two parallel lines. Now look at these two triangles within the two parallel lines, okay? Right? Triangle ABC and triangle PQR. Now remember, the height of the triangle is not drawn, but the height of the triangle is nothing but the distance between the parallel lines. The height of the triangle is distance between the parallel lines. Hence, the height is not drawn. But still, that side which lies on the parallel line becomes a base. So BC becomes a base. Height has been not drawn. QR becomes a base here. Okay? Because the height is nothing but distance between the parallel lines. Are you getting here? Hence, I take BC as a base, QR as a base. So you can see a height has been not drawn, but I am able to tell the base. Are you getting that? This is one example. Another example you can see here, children. I'll put it like this. You can see here, there are, in this picture, there are two triangles, totally three triangles. In this picture, when I draw here, there are totally three triangles. This triangle ABC, in this picture, there are totally three triangles. One is triangle ABD, other is triangle ADC, and the third one is triangle ABC. All have a common vertex. All have a common vertex. And the opposite sides, when you look at the opposite sides, like this red segment is the opposite side of triangle ABD of that common vertex, okay? This green segment is the opposite side of vertex A of the small triangle ADC. And when you look at it, the original triangle, please have a look at triangle ABC, BC is the opposite side of vertex A. So now this BD, then DC and BC, when you look at them, all of them lie on the same line, lie on same line. They have a common vertex, okay? Common vertex, they have common vertex. And opposite side, common vertex, they have got common vertex A. Opposite side of A is BD in triangle ABD, CD in DC in triangle ADC, and in case of triangle ABC, BC, they lie on the same line. Whenever we see this condition, they have a common vertex, alright? The opposite sides lie on the same line. Okay, whenever we see these two conditions, we say the triangles, all the three triangles are equal height. The three triangles are equal height. So three triangles have equal heights. All the three triangles have equal heights. And which are the bases? This side, which lie on the same line, BD, TC, and BC become the bases. BD, EC, and BC become the bases. So here what is up? The triangles have a common vertex and their opposite sides lie on the same straight line. Hence they have equal heights. Correct? So naturally, without drawing the height, but I'm able to say BD is a base, DC is a base, BC is a base of these triangles. Correct? That is what is important here. So in both these cases, you can see, children, here in the first one, I have drawn two parallel lines and the triangles are lying between the two parallel lines. So they have equal height and bases are the sides which lie on the parallel line. And here what you see, children, all the three triangles have a common vertex and the opposite sides of that common vertex of the respective triangles lie on the same line. Correct? Hence these triangles have equal height. So this sides which lie on the same line become the bases. Okay? So here I show you that height of the triangles may not be drawn, but still we are able to identify the base of the triangles. Okay, children? After knowing this, then we can go to the next theorem. Okay, our next theorem, what we're going to learn is a very, very, very important theorem, and I hope you will study it because I'm going to give you the proof also for it, and it is going to come in a board exam. Okay, so please understand. The next very important theorem, children, this will be coming in your board exam. That's I'm going to give the proof of it also. First, let us try to understand the theorem. It's called basic proportionality theorem. What it says is, if a line is parallel to a side of a triangle, intersects the remaining sides at two distinct points, then the line divides the two sides in the same proportion. If a line parallel to a side of a triangle intersects the remaining sides at two distinct points. Then the line divides the two sides in the same proportion. Right. This is what happens is, look here. Right. I said, right, this is, if a line parallel to a side of a triangle intersects the remaining sides of the two at two distinct points, then the line divides the two sides in the same proportion. This is what the statement says. Now, always remember, children, every theorem has two conditions. Okay, keep in mind what I'm trying to say. Every theorem has two conditions. The condition which follows if one condition follows if another condition follows them. The condition following if this condition X is existing, then always use the condition which follows then. Use this. If this condition is not existing, you cannot use this condition. Okay? So remember, if X, then Y. If X is existing, then only you can use Y. So here also you can see this word if, and you can see the word then. So if you see the first condition existing, a line parallel to a side of a triangle intersects the remaining sides at two distinct points. If you see this, what I underlined with red color is existing. A line is parallel to a side of a triangle, and just like this, a line is parallel to a side of a triangle. Like this is a triangle, children. And you can see a line is parallel to a side of a triangle and intersects the remaining two sides at distinct points, like ABC. This line, look at this line, okay, is PQ is parallel to side BC. And it is intersecting the two sides at distinct points, different points P and Q. If you see this condition, then immediately it divides the sides, the two sides in the same ratio, matlab, same proportion, matlab, it divides the two sides in the same ratio. Matlab, AP upon PB is a ratio on this side AB. And what is the ratio on this side AQ upon QC? This ratio is AQ upon QC and AP upon PB are equal. So the moment you see PQ parallel BC, you can come to this conclusion. Any triangle, okay? Suppose there is a triangle XYZ, and you see the condition in this triangle XYZ, you see LM is parallel. LM, just have a look at this LM. LM is parallel to XZ. And don't you agree, LM is intersecting the two sides at distinct points at L and M. So naturally, what will be the formula? YL upon LX is equal to YM upon MZ. This should come to your mind. So whenever you see a line is parallel to a side of a triangle, it intersects, and when a line is parallel to a side of a triangle and intersects the remaining sides at distinct points, then immediately it should come to your mind. It divides the two sides in the same ratio, divides the two sides in the same proportion. Got it? So now, when it comes in your exam, it will not come like this. It will not come like this. In your exam, please have a look at this. Question will come to you. Always prove that. Got it? Prove that. Remember, this question will come to you like this question will come to you like prove that. And it will carry 4 marks. It will carry 4 marks. Prove that, okay? In a statement form. When a question comes in a statement form like this, I call it as a rider. Remember, children, whenever you get a question in the form of a rider, the first thing you have to do is a figure. You have to draw a figure. Now, what is a figure, children? Just identify what condition follows it. That condition helps you to draw the figure. So what is the condition which follows if here? A line parallel to a side of a triangle. Like triangle रहेगा, फिर एक line parallel to a side of a triangle. फिर एक line रहेगा जो parallel to a side रहेगा and intersect the remaining sides at two distinct points. Very easy to draw this figure. Draw a picture. Draw a picture of a triangle, children. I draw a picture of a triangle. You can see here, children. I draw a picture of a triangle. And a line is parallel to a side of a triangle. Line is parallel to a side of a triangle. A line is parallel to a side of a triangle. Yeah. So you can see here, children, a line is also drawn parallel to a side of a triangle. You can see this line, okay, is parallel to a side of a triangle and intersects the remaining sides at distinct points, different points. You can see here. This should be the figure, okay? Now, this, what is given? You have to write given. This given is nothing but, children, picture talk. What it should be? A picture talk of what is given, what you drawn, okay? What you drawn is a triangle. So I'll say in triangle ABC. And what are you seeing? Line PQ is parallel to line PQ is parallel to side BC. Yes, it's parallel to one side of a triangle. And it intersects, line PQ intersects the remaining sides at distinct points. Sides AB and AC, they become the remaining sides, okay, AB and AC in distinct points, P and Q. Distinct points P and Q. So this becomes your given. Line PQ is parallel to side BC and it intersects the remaining sides, that is, intersects the remaining sides AB and BC, AB and AC in points P and Q respectively. And what it proves, that it divides the two sides in the same proportion. You have to prove AP upon PB is equal to AQ upon QC. You have to prove this. Now, how to prove this, children? How to come to prove this, okay? You have to think. So always remember, children, whenever, like if I'm a student, how I would have remembered it. एक ऐसे याद रखते थे इसका proof. Nobody learns by heart. But definitely, the theorem which I taught you before this, okay, this is the second theorem. This is theorem number 2, what you're learning. Earlier, I taught you one theorem number 1. What was that theorem, children? It was on areas of the triangles. Got it? A ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding heights. Ratio of the areas of the triangles having equal heights is equal to ratio of the corresponding bases. Ratio of the areas of the triangles having equal bases is equal to ratio of the corresponding heights. And areas of the two triangles having equal bases and equal heights are equal. I have to use these properties. So let's see how to get AP and PB. Now, when I look at AP can be what triangle APQ? It's the side of triangle APQ. That means AP can be the base. That means actually I want area upon area equal base upon base. Then I can get AP upon PB. मतलब I should get two triangles जिनका heights equal रहेगा और AP और PB उनका bases रहेगा. AP और PB और triangle के bases है. अरे AP तो base है triangle APQ का. लेकिन PB किसका? So you get an idea, children. If I join B to Q, look at triangle APQ, look at triangle BPQ, look at triangle APQ, and look at triangle BPQ. Have a common vertex Q, and their opposite sides AP and PB lie on a same line, Hence, they have equal heights. AP and PB lie on the same line. AP and PB lie on the same line. They have a common vertex Q. Opposite sides, AP and PB lie on the same line. That means these triangles have equal heights. Ratio of the area should be equal to ratio of the bases. So I can write that, children, if you want. Okay, like I got this here. I constructed this. Okay, this construction I have drawn. Okay, this construction I have drawn. Which construction we have drawn, children? You can see here one construction I have drawn. What is that? This BQ. Okay, so what is this BQ, children? I better write here. Okay, construction. What is that? Draw segment BQ. Draw segment BQ. Draw segment BQ. And one more segment I have to draw. I'll just write the name of that. Okay. Now look here. Please have a look at the moment I draw it. Can you see this triangle APB? Triangle APQ and triangle BPQ. Please have a look at them. have equal heights, have equal heights, have equal height. You understand, children? Because why they have equal height? They have a common vertex Q, the opposite side AP for triangle APQ, and PB for triangle PBQ. This AP and PB lie on the same line. Common vertex, the opposite sides lie on the same line. Tells me they have equal heights and AP and PB become the bases. Got it? So naturally, I just wrote in short APQ and BPQ have equal heights. Therefore, area of triangle APQ upon area of triangle BPQ will be equal to, children, please have a look here, will be equal to AP upon PB, and I call this as 1 and write the reason in short, triangles having equal heights have areas proportional to their bases, have areas proportional to their bases. I call this statement number 1, okay? So I got AP upon PB. Now I want AQ upon QC. So we do this segment PC also. Why did we draw segment PC? Triangle APQ दिख रहा है, triangle CPQ दिख रहा है, triangle APQ, triangle CPQ, triangle APQ, triangle CPQ have a common vertex P. The opposite sides AQ in triangle APQ and QC in triangle CPQ. They lie on the same line. So naturally, triangle APQ and triangle CPQ have equal heights, Are you getting me here? Because they have a common vertex and the opposite sides lie on the same line. Whenever the triangles have a common vertex and the opposite sides lie on the same line, we saw in the earlier this, okay, they have equal heights. Now, these triangles have equal heights. So naturally, ratio of the area of triangle APQ upon area of triangle CPQ will be equal to what it will be, children? AQ upon QC. And statement number 2, I'll write the same reason, triangles having equal heights have areas proportional to corresponding bases, have areas proportional to corresponding bases, okay? Now you can see here, children. I got AP upon proportional to that basis or proportional to the corresponding basis. If we don't want to use the word corresponding also chalega, okay? Now look here. AP upon PB, AQ upon QC तो मिल गया, लेकिन ये दोनों equal मांगता है. They are present in my statement number 1 and 2. This right hand side, I want them equal. But if the right hand side you want equal, the left hand side should be equal. So what is the numerator? Numerator, when you look, area of triangle APQ, area numerator the same है. लेकिन ये denominator क्या है? Denominator, when you look at it, children, this is triangle BPQ. Where is your triangle BPQ? You can see here, children, this red triangle is your triangle BPQ. Can you see this triangle BPQ, children? This red triangle is your triangle BPQ, okay? And then now look here. What is the denominator? Triangle CPQ. Where is your triangle CPQ? Now when you look at this triangle, children, this triangle CPQ is your, this triangle CPQ is your green triangle. You can see this green triangle, children. This green triangle is your triangle CPQ. Don't you agree, children? They lie between the same parallel lines. I told you what do you mean by triangles lying between the same parallel lines. The red triangle and the green triangle lie between the same parallel lines. So they have equal heights and also have a common base PQ. They have a common base PQ. That means they have equal bases also. They have equal heights also. So don't you realize, children, okay, the triangles having equal bases and equal heights have equal areas. So naturally, I'll just write triangle is BPQ and triangle TPQ have equal bases on a common base and equal heights because they lie within the same parallel lines. Therefore, area of triangle BPQ is equal to area of triangle CPQ. This I call it as statement number 3. And I write the reason. Areas of the triangles having equal bases and equal heights are equal. Now look at the third statement. When numerators were already the same APQ and APQ, denominators BPQ and CPQ are equal from third statement, you realize? So can I say the left hand side become equal? So can I say the right hand side AP upon PB equal AQ upon QC? Can I say from 1, 2, and 3? From 1, 2, and 3. I think this is the easiest and the shortest proof you can get it for this, okay? I hope it's understood me here. We go to the next theorem now. You can see this converse, okay? Now, how do we write a converse, children? For a minute. We're going to learn converse of basic proportionality theorem. But how do you write a converse? See, just now I told you, children, any theorem has two conditions. One condition follows if, another condition follows then. Now, if I interchange these conditions, like if y को लाता हूँ if के बगल में और x को लाता हूँ then के बगल में, the new statement is called a converse of the above statement. Here, this is converse of BPT. What is BPT? If parallel, simple words, okay, not grammatically right, but just for the sake of understanding. What is basic proportionality theorem? If parallel, then ratios equal. So what is converse? If ratios equal, then parallel. Now I'll put it in a proper English. If a line divides any two sides of a triangle in equal ratios, if a line divides any two sides of a triangle in same ratio, then the line is parallel to the third side. Now what does it mean is, suppose you have a triangle, children. You have a triangle here. You have a triangle here, okay? This is one triangle, okay? And this line, okay? This line, I'm not saying it's parallel. I have not said it's parallel. You cannot believe your eyes. You cannot say, sir, parallel दिखता ना. नहीं, parallel दिया नहीं है. लेकिन क्या दिया है? ये line दोनों साइड पे इंटरसेक्ट कर रहा है. और ये जो रेशियो AP अपॉन PB रेशियो है, is equal to AQ upon QC. अगर ये दिया रहेगा या ये मिलेगा, then we can say PQ, then I can say PQ is parallel to BC. But if a line divides the two sides of a triangle in equal ratio, then only I can say it is parallel to the third side. If this ratio AP upon PB is equal to AQ upon QC, then only I can say PQ parallel BC. Got it? Right. Another one, another example, I'll just show it to you. Right. Please have a look here. Suppose there is a triangle here. Okay? There is a triangle here. There's a triangle here. And this line is intersecting the two sides. This triangle is triangle PQR, and this line is XY. It is intersecting the two sides. Okay? And this length of QX is 2, length of XP is 4, length of QY is 3, length of YR is 6. And they're saying is XY parallel here, is XY. So you're not going to look at it. You're not going to use a scale, but you're going to work it out. You're going to use this property. If a line divides the two sides in equal ratio, then only I can say it is parallel to the third side. So let me find the ratio, okay? What is the ratio here? QX upon XP. कितना है? QX upon XP, 2 upon 4. 2 upon 4 cancel, 1 upon 2. If I say QY upon YR, how much you get? This is 3 upon 6, okay? How much you get? 1 upon 2. Oh, the answers are equal. That means QX upon xp is equal to qy upon yr. Do you agree? The ratios are equal, children, okay? It is dividing the two such an equal ratio. So I can say xy is parallel to PR by converse of BPT, okay, by converse of BPT. So if the line divides any two sides of a triangle in equal ratio, then it is parallel to the third side. Now remember one thing, children, this theorem is not going to be asked in an exam. So I just explained you what is this theorem. Okay, so I'm not going to give the proof of it. It's not going to be asked in your exam. We go to the next theorem now. Now this is a corollary of basic proportionality theorem. What do you mean by corollary? Corollaries are nothing but properties obtained from theorem. Properties obtained or properties derived from theorems. Derived from theorems. Okay. So this is like a corollary of basic proportionality theorem. But this is derived from basic proportionality theorem, and you have to remember this. If you want to find this proof very simple, you'll have to remember this. Okay. Anyway, like a theorem, what does it mean? Okay. The angle bisectors of a triangle. The angle bisector of a triangle divides opposite side in the ratio of the remaining two sides. Matlab, angle bisector of a triangle. Any triangle is that, okay? Any triangle is there. Suppose this is a triangle, okay? Any triangle is there. The angle bisector of a triangle, like this is a triangle, okay? This is the angle bisector, okay? This is the angle bisector. And whenever you see an angle bisector, children, the angle bisector of a triangle divides the opposite side. Like, can you see this angle bisector, children? Okay, this BD is the angle bisector of angle ABC. Divides angle ABC into two equal parts. So angle ABD and angle CBD are equal. So BD is an angle bisector. It divides the opposite side. It divides the opposite side into two parts. You can see here. It divides the opposite side in the ratio. Matlab, ratio of this divided part is equal to ratio of the remaining side. Like see, AD is in the numerator, DC is in the denominator. Then you take it as AB upon AC. Okay. Suppose you take CD in the numerator, CD upon AD, if you would have taken ratio, then CD can BC. So BC over BC upon AB. Are you getting me here? So angle bisector of a triangle divides the opposite side in the ratio of the remaining two sides. Whenever you see an angle bisector, this formula should come to your mind. Like any triangle, children. Suppose this is a triangle PQR, okay? And you see RS is the angle bisector. What is this? RS is the angle bisector. RS is the angle bisector, okay? RS. So what will be the proof? What will be the property, children? PS upon SQ. Angle bisector divides the opposite side in the ratio of the remaining sides. So PS upon SQ. PS in the numerator. So PR in the numerator. PR upon QR. Angle bisector divides opposite side in the ratio of the remaining two sides. Okay. Angle bisector divides opposite side in the ratio of the remaining two sides. But this theorem, I hope everybody understood. But whenever you see an angle bisector, this formula should come to your mind. This formula should come to your mind. Now remember, children, this is going to be asked. The proof of this can be asked in your board exam. The proof of it can be asked in your exam. This is a very important one. So we have to do this proof, okay? So listen, how it will come in your exam, okay? It will just come like this. It will come, prove that the angle bisector of a triangle divides the opposite side in the ratio of the remaining two sides. Prove that the angle bisector of a triangle divides the opposite side in the ratio of the remaining sides. Children, ये बराबर स्टेटमेंट को आप देखेंगे ना, ये स्टेटमेंट आपको कुछ करने को बोल रहा है, जैसे एक एक्शन करने को बोल रहा है. जैसे मैं एक एक्शन बोलता हूँ, शो दैट यू कैन राइड अ मोटरसाइकिल. एक्शन है, तो वो एक्शन करने के लिए क्या रहनी चाहिए? मोटरसाइकिल. करेक्ट. शो दैट यू कैन राइट विद अ पेन. ये एक्शन करने के लिए क्या रहनी चाहिए? आपको पेन और नोटबुक रहनी चाहिए. तो वैसे ही दिमाग लगाइए इसमें. Prove that the angle bisector of a triangle divides the opposite side in the ratio of the remaining sides. Angle bisector of a triangle. मतलब क्या रहनी चाहिए आपके पास? आपके पास एक ट्रायंगल, और ट्रायंगल के बाद वो ट्रायंगल का angle bisector. Okay, that is, you should have a triangle. You should have a triangle like this, children. And also, you should have an angle bisector in the triangle. Like, let me say, this is an angle bisector of a triangle. Okay, I've drawn it like this for the sake of proof. Okay, this is my triangle ABC. And this is my ABC. Okay, this AD is my angle bisector. Okay, angle bisector of a triangle. And what you want to prove? Got it? Divide the opposite side in the ratio of the remaining sides. That means what is given to us? Given is, please have a look here. In triangle ABC, in triangle ABC, the picture talk given is nothing but the picture talk. What else given? A triangle and angle bisector. In triangle ABC, ray AD is angle bisector of angle BAC. And where is this D line? D lies on BC. Matlab B dash, B dash, B dash, D dash C, B dash, D dash C, B dash, D dash C. Okay. And what do you want to prove that? You want to prove that angle bisector divides the opposite side in the ratio of the remaining ratio equal to remaining two sides. Ratio of the remaining two sides. Matlab BD upon DC, I want to prove it is equal to AB upon AC. Like I told you, children, this is a corollary of basic proportionality theorem. This is a corollary of basic proportionality theorem. That means आपको इसमें ये theorem में आपको basic proportionality theorem use करना ही पड़ेगा. आपको basic proportionality theorem use करना पड़ेगा. लेकिन अभी the basic proportionality theorem, how to use it, children? How to use basic proportionality theorem? So I'll just help you, children. See, you want BD upon DC. How you want the ratio BD upon DC on the left hand side, which is a dividing line. AD is a dividing line. So I realize in a triangle, if I have a triangle like this, children, just have an imagine, okay? If I have a triangle, please have a look here. If I have a triangle like this, I'll just put it like this. Just try to understand. Just try to remember, okay? If I have a triangle, listen. If I have a triangle like this, children. If I have a triangle like this, like BD, BDC, and suppose this is your A, and whatever it is, Q, whatever you call it, okay? What do I call it? Q. Now, if I have AD parallel QC, then I can have BD upon BC equal AB upon AC basic proportionality theorem. So if, in a basic proportionality theorem, the parallel line is the dividing line. Here, AD is the dividing line. I want BD upon DC. In a basic proportionality theorem, देखो एक triangle एक QBC मैंने draw किया है ऐसे, अगर AD parallel QC रहेगा तो हमको BD upon DC मिल सकता है. BD upon DC equal AB upon AQ. अगर AD parallel QC रहेगा तो either AD should be parallel. AD is the dividing line. AD is the see the parallel line is the dividing line. So AD should become the parallel line to a side. So side किधर रहेगा? बाहर रहेगा. So that is what I'm trying to say. Yeah, I get an idea. I'm going to construct a line passing through C. Got it? I'm going to construct a line passing through C parallel to AD and intersecting, you can see here, intersecting your BA at intersecting BA at Q. Intersecting BA at Q. You can see here, children, I have drawn a line, okay? I have drawn a line through C parallel to AD. See, this is also construction of CQ. I draw a line passing through C parallel to AD, intersecting BA produced at Q. So what is construction, children? Construction. Draw a line. Draw a line. Draw a line, okay? Passing through C, parallel to AD, parallel to segment AD, and intersecting intersecting, intersecting BA produced at Q, BA produced at Q. So draw a line passing through. You can see your children. I've drawn a line passing through. I've drawn a line passing through. Please pay attention. Draw a line passing through C. Parallel to draw a line passing through C. Parallel to AD. And intersecting BA produced at Q. I hope people can understand this. This is line. Okay. Draw a line passing through. Draw a line passing through C. Parallel to segment AD. And intersecting BA produced at Q. Now, why did I draw it? Like I told you, children, when you look at this, okay, you want the answer, you want in your answer BD upon, you want in your answer BD upon DC. You can see a BD upon DC. Abhi BD upon DC आराम से मिल सकता है. Look at the biggest triangle in the figure. Can you see the biggest triangle in the figure QBC? Can you see the biggest triangle in the figure QBC? And don't you realize segment AD is parallel to segment QC by consection. By consection. So naturally, whenever you see a line is parallel to one side of a triangle, intersects the two sides at distinct points, I can say divide the two sides in equal ratio. So BD upon DC is equal to AB upon AQ. I call this as statement number 1. I say by basic proportionality theorem. I write in short. Now you compare what have you got with the answer. BD मिल गया upon DC equal AB. The problem है AQ का. Whereas in place of AQ, what I want AC. In place of AQ, what I want? In place of AC, AQ. In place of this AQ, I want this AC. I want this AC. In place of AQ, I want AC. That means AQ और AC को equal दिखाना है. AQ और AC को equal दिखाना है. AQ और AC को equal दिखाना है. How can I show AQ and AC equal, children? How can I show AQ and AC equal? That is possible. AQ and AC equal. That is possible if you can show this angle number 1 and angle number 2 equal. If angle 1 equal angle 2, you can always say AQ equal AC. By converse of isosceles triangle theorem. लेकिन 1 और 2 equal कैसा दिखाऊंगा? 1 और 2 equal कैसा दिखाऊंगा? तो जरा सोचो चिल्ड्रन. ये गिवन ये जो भी किया है वो ही हिंट है. ये 1 किसका साथ इक्वल है? 2 जाने तो प्रूव करना है. 1 और 2 को इक्वल दिखाना है. लेकिन 1 किसका साथ इक्वल है? तो देखो AD पैरेलल QC. तो 1 equal 3. Don't you agree? Alternate angles. 1 equal 3 alternate angles. 1 equal 3 alternate angles. Now what is this 2 equal to? आपको 1 और 2 equal दिखाना है. तो 2 किसका साथ इक्वल है? बराबर देखिएगा. 2 equal 4 corresponding angles. When the lines are parallel and cut by transversal, corresponding angles are equal. But don't you realize 3 and 4 are equal? 3 and 4 are equal. Angle 3 and angle 4 are equal. So angle 1 and 2 will be equal. See, 1 is equal to 3. 2 is equal to 4. But 3 and 4 are equal. Therefore, 1 equal to 1 equal 3. 2 equal 4. But 3 and 4 are equal. Therefore, 1 equal 2 I can say. And if 1 and 2 are equal, I can say AQ equal AC. और अब AQ और AC equal हो गया तो इसको AQ का जगह में AC लिख देंगे. आंसर मिल गया. So see how we go about. Already these two lines AD parallel BC are already shown on top. So on transversal AC, just have a look at this transversal AC. Okay, your angle 1. What is the name of it? Angle ACQ. Angle ACQ is equal to angle CAD. What is the reason for it, children? Reason for it is alternate angles theorem. By alternate angles theorem. By alternate angles theorem. Children, you can see clearly. This is nothing but ACQ equals CAD. Matlab 1 equal 3. And what is this angle on transversal? On transversal QD. On this transversal QB. On transversal QB. Your angle AQC is equal to angle BAD. What is the reason, children? By statement number 3. by corresponding angles theorem, corresponding angles theorem. Now look here, but angle CAD is equal to angle BAD is given to you because bisector diya hai beta. Statement number 4, this is given. So from statement number 4, you realize the right hand side of 2 and 3 are equal. CAD and this BAD are equal. This right hand sides are equal. From fourth statement, you realize the right hand side of 2 and 3 are equal. From fourth statement, you realize right hand side of 2 and 3 are equal. So I can say ACQ equal AQC. That means in this triangle ACQ or AQC, what you see? Angle ACQ is equal to angle AQC. Reason is from 2, 3, and 4. From 2, 3, and 4. Now, whenever two angles of a triangle are equal, the opposite sides are equal. Therefore, can I say, children, AQ equal AC, statement number 5, converse of isosceles triangle theorem, by converse of isosceles triangle theorem, Now you can see yourself, children, AQ and AC are equal. So I got this AQ equal to AC. So can I replace this AQ by AC? Statement number 1 में AQ का जगह में AC डालूंगा. So I'll rewrite statement number 1. Therefore, BD upon DC is equal to AB upon AC. Can I say from 1 and 5? From 1 and 5. I hope people can understand this and can get me a very simple proof, but very important. Surely it can be asked in your exam. We go to the next theorem now. This is the next theorem, children. Property of three parallel lines and the transversal. Name is property of three parallel lines and the transversal. Now what it says is the ratio of the intercepts made by three parallel lines on a transversal. Three parallel lines, you can see here, suppose line L is parallel line M, parallel line N. These are three parallel lines. Can you see this X is a transversal? Now, this segment which lies on the transversal exactly between the parallel lines is called an intercept. AB is an intercept. BC is an intercept, which lies on this segment, which lies on the transversal, but exactly between the parallel lines is called an intercept. Even AC is an intercept. So what the question says is the ratio of the intercepts made by three parallel lines on the transversal. Means take a ratio of this intercept. AB upon BC you take. Then this is the same three parallel lines again having another transversal, and which are the corresponding intercepts, matching intercepts for AB and BC is PQ and QR. So if AB upon BC will be equal to PQ upon QR. If we take the ratio of AB and BC, ratio of this intercept, it will be equal to the ratio of the corresponding intercepts PQ upon QR. If we take AB upon AC, it should be PQ upon PR. If we take BC upon AB, it should be QR upon PQ. The way you take the ratios of the intercepts here, the same way you should take the ratio of the corresponding intercepts on the other side. Only requirement is the three parallel lines and the two transversals are the requirement. Got it? So whenever you see three parallel lines like line L, parallel line M, parallel line N here, do you agree? And lines X and Y are the transversals, for these two parallel lines, three parallel lines. Therefore, ratio of the intercepts AB upon BC will be equal to the ratio of the corresponding intercepts on the other transversal, PQ upon QR. Got it? Reason by property of three parallel lines, by property of three parallel lines, and their transversal, okay? Three parallel and their transversal. Okay, children, very simple. We'll see this theorem later on, okay? Now, move ahead. We go to the next theorem now. So before we go to the next theorem, let us introduce a concept of similar figures. What do you mean by similar figures? Children, the figures, please hear, all congruent figures are similar figures, but all similar figures are not congruent figures. All may not be congruent figures. So what do you mean by these similar figures? Very simple, children. I'll put it in very easy words. Suppose you have your photograph, okay? And I enlarge this photograph. I enlarge this photograph. You have your photograph and I enlarge that photograph, okay? Now what happens? That photograph and what you enlarged photograph, okay? Xerox copy in an enlarged one, okay? When I compare both the photographs, I can say they're identical. They are identical, only the sizes are not the same. So such figures which are identical but may not be of the same size, we call them as similar figures. That means, what do you mean by similar figures, sir? Figures which have the same shape but not necessarily same size are called similar figures. Figures which have a same shape, but not necessarily the same size. Are called similar figures. Figures which have the same shape, but not necessarily the same size. I told you, Xerox photograph, a photograph of yours, and I remove a Xerox copy of it, which is an enlarged copy. Now, when I look at both the figures, they are identical, but not of the same size. They are different size. We call them as similar figures. That's the best fit answer for similar figures. Are you getting me here? Now, in the same way, children, only problem is about, like, when you talk about the triangles, there is a complication arises. A triangle is a three-sided figure. So you'll say the shape is same. No, you can get triangles of different shapes. So naturally, when you draw two triangles, they may not be similar. So when are two triangles said to be similar? Two triangles are said to be similar when they satisfy two conditions, okay? One is the ratio of the corresponding sides should come equal. The ratio of the corresponding sides should be equal. And the second one, the corresponding angle should be equal. I repeat, suppose there are two triangles, the one-to-one correspondence between the vertices of two triangles is PQR. In this correspondence, if you see the two conditions, AB upon PQ is equal to BC upon QR, BEC, and the second and third letter QR. BC upon QR equal first and third letter AAC, first and third letter PR. This ratio of the corresponding sides are equal and the corresponding angles are equal. Angle A equal angle P, angle B equal angle Q, and angle C equal angle R. Then I can say the two triangles are similar. This whole thing, see, if in a particular one-to-one correspondence between the vertices, the ratio of the corresponding sides are equal and the corresponding angles are congruent. Then the two triangles are similar. Now, when you see this, remember, this is a symbol for similar. Okay, triangle ABC similar triangle PQR. Triangle ABC similar triangle PQR. So remember, children, if in a particular one-to-one correspondence between the vertices of two triangles, okay, the ratio of the corresponding sides are equal and the corresponding angles are congruent, then the two triangles are said to be similar. Then this is called the definition of similar triangles. If in a proper one-to-one correspondence, in a particular one-to-one correspondence between the vertices of two triangles, the ratio of the corresponding sides are equal and the corresponding angles are congruent, then I can say the triangles are similar. This is the definition of similar triangles. This is the definition of similar triangles, okay? This is the definition of similar triangles. What is that? If in a particular one-to-one correspondence between the vertices of two triangles, the ratio of the corresponding sides are equal and the corresponding angles are congruent, then the two triangles are similar. Okay. Now, converse, if you see anywhere triangle ABC, similar triangle PQR, you know what is the meaning of similar? Okay. They are identical triangles, but the sizes need not be same. If triangle ABC is similar triangle PQR, if you happen to see somewhere, then immediately the formula should come to your mind regarding the size. Ratio of the corresponding sides are equal. AB upon PQ equal BC upon QR equal AC upon PR. And corresponding angles are congruent. Angle A, congruent angle P. Angle B, congruent angle Q. Angle C, congruent angle R. I hope people have understood the difference between this and this. Okay, here you see this condition. Ratio of the corresponding sides are equal and corresponding angles are congruent. Then I say the triangle is similar. लेकिन इधर क्या सेकंड वाला इसमें क्या दिया? अगर ट्रायंगल सिमिलर है तो आपके दिमाग में क्या आनी चाहिए? ये दो प्रॉपर्टी. The ratio of the corresponding sides are equal and the corresponding angles are congruent. Are you getting me, children? Remember this, okay? Now, I'll just say, so whenever two triangles are there, how will I come to know whether these two triangles are similar or not, okay? Two triangles are there. How will I come to know whether the two triangles are similar or not? To find out whether two triangles are similar or not, we are going to learn some test of similarity. We are going to learn some test of similarity. Test of similarity. Test of similarity. मतलब दो triangle similar है क्या नहीं पता लगाने के लिए आपको test सिखा रहा हूँ. Okay. First test is called double A test. In short, double A test. Like the name suggests, if two angles of one triangle are respective, anytime you see like this, two triangles are there. Okay, two triangles are there. Then you see that one pair of angles are, two pair of angles are congruent. Two pair of angles are congruent. Like you can see this triangle ABC and triangle PQR. And what you realize, angle B is equal congruent to angle Q. Both are marked with the same sign. Angle C congruent to angle R. Both are marked with the same sign. So two angles of one triangle are respectively congruent to two angles of the other triangle. The moment you see like this, I can say both the triangles are similar by a test. So when two angles of one triangle are congruent to two angles of other triangle, I can say both the triangles are similar by a test. If two angles of one triangle are congruent to two angles of other triangle, I can say both the triangles are similar by a test. The second one, SAS test, okay? What is SAS test of similarity? If ratio of one pair of corresponding sides is equal to ratio of the other pair of corresponding sides, like two triangles are there, correct? Two triangles are there, children. If you see any time the ratio of one pair of corresponding sides, like AB upon PQ, okay, is equal to BC upon QR. Now you can see, children, this is ratio of only one pair of corresponding sides is equal to ratio of the other pair of corresponding sides, children. And look, AB and BC may B letter common hai. So angle B is called an included angle of AB and BC. PQ and QR may angle Q is common. Q is called an included angle of PQ and QR. And these included angles are congruent. You see the included angles are congruent. So when you see this condition, ratio of one pair of corresponding sides is equal to ratio of the other pair of corresponding sides. And the included angles are congruent. Angle B congruent, angle Q. At once I can say both the triangles are similar by SAS test of similarity. Got it? And the last one for seeing whether two triangles are similar or not. It is when the ratio of all the three pairs of corresponding sides of one triangle of the two triangles are equal, ratio of all the three pairs of corresponding sides, AB upon PQ, equal BC upon QR, equal AC upon PR. Ratio of all the three pairs of corresponding sides are equal. When you see this condition, ratio of all the three pairs of corresponding sides are equal, like AB upon PQ, equal BC upon QR, equal AC upon PR. Then I can say both the triangles are similar by SSS test of similarity. So usually these are the three tests of similarities we'll be using. In 80% of the sums, will be using A test, 15% of the sums will be using SAS, and hardly 5% of the sums will be seeing where SSS test we use. Okay, very simple, children, very simple. I hope people understand. You should know this to understand the next theorem what you're going to learn. Okay, children. Now, this is theorem on areas of similar triangles, a very important theorem. The proof of this theorem can be asked in a board exam. Okay, so we'll be doing that also. The ratio, let's try to understand the theorem. The ratio of the areas of two similar triangles is equal to ratio of the square of the corresponding side. Ratio of the areas of two similar triangles. Now, there are two triangles. And these two triangles, was triangle ABC and triangle PQ. They're two similar triangles. Then, if they are similar, if these triangles are similar, then the ratio of the areas of the similar triangles, is equal to ratio of the square of the corresponding sides. That is, AB corresponding side is PQ. So AB square upon PQ square, or it is equal to BC square upon BC's corresponding side is QR. So BC square upon QR square, or it is equal to AC square upon PR square. So remember, if the triangles are similar, the ratio of the areas is equal to ratio of the square of the corresponding sides. Okay. So this, you can use this theorem only on if the condition needed is the triangle should be similar. Now, after understanding this theorem, let's try to prove it. Okay. Now, the proof will be just in an exam, it will come. Prove that ratio of the areas of two similar triangles. If you are asked to prove like this, prove that the ratio of the areas of two similar triangles. Prove that the ratio of the areas of two similar triangles is equal to ratio of the square of the corresponding sides. That means what is given is, try to understand, okay, two similar triangles. What is given is two similar triangles. What is given is two similar triangles. So I will draw two similar triangles. Okay, two similar triangles. See, I have drawn two similar triangles. एक छोटा एक बड़ा. जब भी similar triangles लेंगे तो एक छोटा एक बड़ा ले लेंगे. Okay. Now I have drawn two similar triangles. I'll name one as ABC. I'll name one as ABC. Triangle ABC, and the other one as triangle PQR. So what is given is two similar triangles. Okay, what is given is this two similar triangles. This triangle ABC, similar triangle PQR. These two are similar is given to us. And what do you want to prove that? The ratio of the areas of this triangle, area of triangle ABC upon area of triangle PQR is equal to ratio of the squares of the corresponding side. AB square upon PQ square equal BC square upon QR square is equal to AC square upon PR square. So how are we going to prove this? Okay. So remember, children, how we go about it. Okay. I have to prove it. So first, what comes to your mind is the construction. Why at all the construction comes to your mind? I have to do a construction because see, these two triangles are similar, and they want me to get the ratio of the areas. For ratio of the areas, we have learned a property. It says ratio of the areas of two triangles earlier, like earlier to this, we have learned only one property, which says ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding heights. So I would like to get those bases of corresponding, bases and corresponding height. But a base is determined only when there is a height of it. So what am I going to do is I'm going to draw a height for this triangle. I'm going to draw a height for this triangle. Like which triangle you can see, children? Like triangle ABC. Can you see this? I'm going to draw this triangle dotted line. Okay, I draw this AD perpendicular to BC. I draw PQ, PS perpendicular to, I draw PS perpendicular to QR. Okay, I draw QS perpendicular to, I draw AD perpendicular to BC, beta. I draw PS perpendicular to QR. I construct this height. Okay. Why did I construct the height? Because the heights help us to say the identify the base. Now I know BC is the base, AD is the height. I know QR is the base, PS is the height. So my property use pile property. Okay. So construction draw. What is that? Draw segment AD perpendicular segment BC and segment QR PS perpendicular segment QR. So now what has happened, you can clearly see, children, the two triangles, okay, you can see the two triangles and they have bases and heights, okay. So naturally, I want in my proof ratio of the areas of the triangle. So naturally, I can start with that very first theorem, okay. Area of triangle ABC upon area of triangle PQR is equal to ratio of the areas of two triangles is equal to ratio of the product of the bases and corresponding heights, which is the base of the first triangle BC, which is the height of it AD. So base into height BC into AD upon what I did here QR into PS, QR into PS, okay. And I'll write the reason ratio of the areas, the first theorem, okay. Ratio of the areas of two triangles is equal to ratio of the product of bases, product of bases and corresponding heights So I'm getting a ratio of areas of two triangles is equal to ratio of the product of bases and corresponding heights. I call this as statement number 1. I call this as statement number 1. I call it as statement number 1. I call it statement number 1. But I know, children, in my answer, I want AB square upon PQ square. That is possible when I do area of triangle ABC upon area of triangle PQR as AB into AB upon PQ into PQ. Matlab, BC or this AB BC upon QR, that is ratio of the bases, BC upon QR, I'll change it to AB upon PQ. I'll just one more step and then you'll understand better. So the area of triangle ABC, what I do, no reason for it because the same reason statement, okay, upon area of triangle PQR, what I do, I just write BC upon QR, that is ratio of the bases separate into ratio of the heights, AD upon PS. So now you know, I want the first ratio AB square upon PQ square. That means I want to show this BC upon QR as AB upon PQ, BC upon QR as AB upon PQ. But how can I show BC upon QR equal AB upon PQ? How can I show this ratio is equal? They are equal because these triangles are similar. These triangles are similar. So naturally, this is my statement number 1. Sorry, I will not take the earlier as statement number 1. I will not take this as statement number 1. Okay, this as statement number 1. So this you can see here, children. Statement number 1, this BC upon QR, I want AB upon PQ in place of it. So I will say this triangle ABC is similar triangle PQR given. Therefore, naturally, you don't want this BC upon QR. So can you see this BC upon QR, ratio of the corresponding sides? Can you see BC upon QR is equal to, can I push it as AB upon PQ? Yes, why? Statement number 2, corresponding sides of similar triangles. Corresponding sides of similar triangles. That means in place of BC upon QR, I can always put AB upon PQ. अभी मुझे AD upon PS को भी equal दिखाना है AB upon PQ, so that I can replace this AD upon PS also by AB upon PQ. Now, how to show this ratio is equal? This you can show it equal only after proving these two triangles similar. Because when the triangles are similar, then only the ratio of the corresponding sides are equal. So AD and AB, when you look at it, triangle ADB. Can you see this triangle ADB? AD and AB are the sides. And can you see this? PS and PQ belongs to triangle PSQ. So when you look at this triangle, in triangle ADB, and triangle PSQ. Can you see these two triangles? Can I say angle ADB congruent angle PSQ each is 90? These angles are congruent because each is 90 degrees. But what about angle B? Angle B is congruent to angle Q. I can say it because they are corresponding angles of the big similar triangles. You know, the big triangles are similar. The corresponding angles of similar triangles. Corresponding angles of similar triangles. So naturally, what will happen, children? Corresponding angles of similar triangles. So what is happening is, naturally, I can say both the small triangles, triangle ADB is similar to, can I say therefore triangle ADB is similar to triangle PSQ by AA test, Both these triangles are similar by AA test. Now you can see, children, your AD which you want, AD upon PS, what is it equal to? AB upon PQ. AB upon PQ. Can I call this as statement number 3, corresponding sides of similar triangles? Corresponding sides of similar triangles, in short. So now you can see the first ratio BC upon Q are equal AB upon PQ in statement number 2. That in the first ratio AD upon PS equal AB upon PQ in statement number 3. So can I rewrite the area of triangle ABC upon area of triangle PQR is equal to, what will happen, children? AB upon PQ into AB upon PQ, and I'll write the reason as, I was able to write this from 1, 2, and 3. 1, 2, and 3. So what happens, therefore area of triangle ABC upon area of triangle PQR, ratio of the areas of two similar triangles is equal to ratio of the square of the corresponding sides I get. But you see, the way I want my answer, I want all the squares. So, you know, but AB upon PQ is equal to BC upon QR is equal to AC upon PR. Statement number 5, corresponding sides of similar triangles. Therefore, now you understand, therefore, area of triangle ABC upon area of triangle PQR is equal to, what will happen, children? AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square from 4 and 5, okay? So with this, the theorems of the first chapter gets over, children. If you go through these theorems, I'm sure you'll be able to understand this chapter also, and also these theorems are helpful for your exam. Please go through it. Keep your notebook ready and start writing, looking at it. Take a pause the video and write, pause the video and write. That is how you're going to study, children. Anyhow, we go to the next lecture. Now, in the next lecture, I'm going to do some extra sums of similarity.